Just looking at some examples, this is where we finished off in the last video, what a permutation of a set is. So the number of permutations of an n-member set, that is the number of distinct orderings of the set, that's a full set, is npn or n factorial, okay? We had just finished this off as well in the last video, that NPR is the number of ways of choosing in order, where order matters, are objects from n. And that is n factorial over n minus r factorial. So for example, 16p4 is 16 factorial over 12 factorial, okay? So if you want to order a complete set, in how many ways can I order 8 people in a straight line, that would be 8 factorial. So that's what this one is. The number of permutations of an n-member set. So that's from n, I'm ordering n. So that's npn, or just, we'd never write it as npn. We write it as n factorial. So npn is actually n factorial. Now, just another example. So this, now we're going to do some ordering where there are restrictions, okay? So here we've got restrictions. 8 people form 2 queues, each with 4 people. So I like to do this, okay? They're my 2 queues, okay? Albert will only stand in the left-hand queue. So this is my left-hand queue, and this is my right-hand queue. So Albert will only stand in one of these 4 places, and Beth will only stand in the right-hand queue, so she will only stand in one of those 4 places. And Charles and Diana insist on standing in the same queue. There are ways in which the 2 queues can be formed. We know that Albert will only go in one of these 4 places, so let's just put Albert in. He's got 4 choices, okay? Beth will only stand in the right-hand queue, so she's got 4 choices as well. Now, so I'm just going to put them anywhere down. They have to go in one of those 4 places. So I'm just going to put Albert here, Beth here. But they're not necessarily at the end. But they could, Albert could have been 1, 2, 3, 4. Beth could have been 1, 2, 3, 4. But I'm just putting them down anywhere so that I know that now there's only 3 places left. Now, Charles and Diana insist on standing in the same queue. So going to do, let's just put Charles somewhere first. Now Charles could go 1, 2, 3, 4, 5, 6. Charles has got 6 choices, okay? Now it doesn't matter where he went, I'm just going to drop him somewhere, but let's say he went here, okay? But he could have gone there, or there, but I'm just putting him down in a place so that I can see that a place is taken. Diana has now how many choices? Only 2. Okay. Now, then we've got how many other people? So I'll just put Diana here, for example, but she did have 2 choices. So now there's 1, 2, 3, 4 places left for the 4 other people. So how do I do that? Times 4 factorial. So the next person has 1, 2, 3, 4. Then the next one will have 3 choices. Then the next one will have 2. And the last one will have 1. So that is the other 4 people. So this, have we got an answer for that? 4,608 ways, wow, that they can be arranged in the queue. Okay? Now look, later we're going to do examples where you put these 2 together as a group.